This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to the discussion. Today, we're diving into a fascinating Google patent application: virtual brain cloning, telepathic data communications with virtual reality holographic projections using artificial intelligence. It sounds like science fiction, but the implications are potentially groundbreaking.
Indeed. The patent explores the possibility of using AI to create a virtual replica of a brain, enabling a form of telepathic communication through VR.
Telepathic communication? That's quite a claim. How would such a system even work?
The patent suggests using advanced AI to map and model brain activity, essentially creating a digital twin. This digital twin could then interact with a VR environment, allowing for communication and interaction in a way that mimics telepathy.
So a digital representation of your thoughts and consciousness projected into a virtual world? That's mind-blowing. Let's start with the core concept: brain mapping and modeling. How feasible is it to create a truly accurate digital representation of a human brain?
It's a monumental task, of course. The human brain is incredibly complex, with billions of neurons and trillions of connections. However, advancements in neuroimaging and AI are making it increasingly possible to map brain activity with greater precision. The patent likely envisions using techniques like fMRI and EEG, combined with powerful machine learning algorithms, to build a detailed model.
And what about the ethical implications of such detailed brain mapping? Privacy concerns must be paramount.
Absolutely. The ethical considerations are significant. The patent would need to address data security and privacy rigorously. Anonymization and secure storage of brain data are crucial to prevent misuse. Furthermore, informed consent would be paramount.
The patent mentions the integration of AI and virtual reality. How would these technologies work together to facilitate this telepathic communication?
The AI model of the brain would act as an intermediary. It would interpret the brain activity patterns, translate them into digital signals, and then project those signals into the VR environment as actions or communications. The VR system would provide the visual and interactive interface for this communication. Imagine a scenario where your thoughts directly control an avatar in a virtual world, allowing you to communicate with others in a seamless, intuitive way.
So the VR environment acts as a kind of interface for the digital brain.
Precisely. It's the medium through which the AI-interpreted brain activity is expressed and shared. The patent likely envisions a highly immersive and responsive VR experience tailored to the individual's brain model.
The term telepathic communication is certainly attention-grabbing. How accurately does this system reflect true telepathy?
It's important to clarify that this isn't true telepathy in the mystical sense. It's a technologically mediated form of communication that mimics some aspects of telepathy. The system relies on interpreting brain activity and translating it into digital signals. It's not a direct mind-to-mind connection.
What are some of the limitations of this proposed system?
Several challenges remain. The accuracy of brain mapping and the ability of the AI to interpret complex brain activity are crucial. The system's effectiveness would depend heavily on the quality of the brain model and the sophistication of the AI algorithms. Furthermore, the technology would need to be robust and reliable to avoid misinterpretations or errors in communication.
Beyond communication, what other potential applications does this technology hold?
The potential applications are vast. It could revolutionize human-computer interaction, allowing for more intuitive and seamless control of devices and systems. It could also have significant implications for healthcare, enabling new forms of therapy and rehabilitation. Imagine using this technology to help patients with communication disorders or to provide immersive training simulations.
And what about the broader societal impact? Could this technology lead to unforeseen consequences?
The societal impact is a complex issue. The technology could enhance communication and collaboration, but it could also raise concerns about privacy, security, and potential misuse. Careful consideration of ethical implications and the development of appropriate regulations are crucial to ensure responsible development and deployment.
How far away are we from seeing this technology become a reality? What are the major technological hurdles?
The technology is still in its early stages. Significant advancements in brain-computer interfaces, AI, and VR are needed. The accuracy and reliability of brain mapping, the sophistication of AI algorithms, and the development of robust and user-friendly VR interfaces are all critical challenges. Overcoming these hurdles will require substantial research and development efforts.
So it's a long-term project, but the potential rewards are significant.
Absolutely. The potential benefits are immense, but responsible development and deployment are crucial to ensure that this technology is used for the betterment of humanity.
What are some of the key areas of future research that would need to be addressed to make this technology a reality?
Further research is needed in several areas. Improving the accuracy and resolution of brain mapping techniques is crucial. Developing more sophisticated AI algorithms capable of interpreting complex brain activity patterns is also essential. Advances in VR technology are needed to create more immersive and responsive virtual environments. And finally, extensive research on the ethical, social, and legal implications is necessary to ensure responsible development and deployment.
It sounds like a multidisciplinary effort is required.
Indeed, this technology requires collaboration between neuroscientists, computer scientists, engineers, ethicists, and policymakers.
This patent application presents a truly ambitious vision for the future of communication and human-computer interaction. While significant challenges remain, the potential benefits are undeniable.
The concept of virtual brain cloning and telepathic communication through VR is a fascinating exploration of the intersection of neuroscience, AI, and virtual reality. While the technology is still in its infancy, the potential for transformative applications is clear. However, careful consideration of ethical implications and responsible development are paramount.
That was a great discussion. Thank you for your insights.